Okay, so section 9.5, this is it. We are not going to do 9.10. So even though we've readjusted, and 9.10 is not a bad thing to do, it's just that I want you guys doing the word problems and working together on the word problems. So tomorrow in class is another work day. Get all the technique stuff done before class. I want you all the technique stuff done. Get in here tomorrow and work on your word problems. That's my expectation. Are you with me there? Okay, so that there's discussion that's happening, what's working, what's not working, those types of things. Okay, so solving linear systems that have more than two variables. What happens if you have x, y, z? We can't graph this on our calculators and look for where they intersect unless you have a TI-89 because it's three-dimensional. And TI-89s will graph three-dimensional for you so you can rotate around what's happening and take a peek at all the angles, and they're really kind of cool. I've never had to own one. I was able to rent it from the university. You give them a check for $100 and you use it for the semester, and when you return it, you get your $100 check back. It's kind of cool. Okay, now my guess is there's some cool apps out there that will let you graph three-dimensionally that you all might know more about than I do. If you find something out there that's cool, share it so that I can kind of learn as we go through. Okay, that being said, algebraically, what do we do? How do we find? We're looking for those ordered triples. Some of your numbers are not going to be very nice numbers. Like these are all nasty kind of looking fractions as we get done. And some of yours on your assignment are going to be nasty looking fractions. Okay, so if you get nasty looking fractions, know, hey, it might be okay. Don't let it be that it's wrong. So as you're looking at your three equations with your three variables, think about what you can do to use elimination. In 9.1, in our first section that we were using and we were solving and looking for intersections, we had one set of three with three unknowns that we said, hey, use the first two, get rid of the z's. Use the second two, get rid of the z's. Now you're down to just x and y. Solve that system, plug it back in to find the matching z. Okay, what we're looking for here is we're looking for an ordered triple. Your x, y, z is the way your answer is going to go. Now maybe you're in some problem that has A, B, C. Your ordered triple, just like your ordered pairs, will always be in alphabetical order. So you don't have to question how is it going to be formatted in that particular part. Okay. All right, here we go. So let's look to see what we can get rid of here. I'm looking at this third equation and what letter's missing? Y. So if we use the top two equations to get rid of the y, then I'm down to a system of equations that just has two equations and we know how to solve that part of it. So right here, if this was a -2, so if I multiply this one by a +2, I'm going to get 4x minus 2y plus 2z equals 8. Okay. Adding the new equation with the second equation, because they're opposites, we get 7x and we get plus 3z equals 9. This is now the system that we know how to solve. We're going to get x and we're going to get z. We're going to plug them back into either of the equations to get what we have going on. Okay. So what do you want to do to solve these ones? Randy, what would you do to solve the bottom two? So, oh, you want to use substitution and plug it back in? Okay. If we solve for x, we get x equals, we add the 2z to the other side, 2z plus 7. We're going to plug it in here. You could have multiplied the top by -7 and gotten rid of your x's as well, or multiplied the top by 3 and the bottom by 2 and got rid of your z's, either way. 7 times 2z plus 7 plus 3z equals 9. Simplifying, 14z plus 49 plus 3z equals 9. Combining our like terms, 17z equals, moving that 49 to the other side, -40. So z is -40/17. Like I said, They might be nasty looking fractions, okay? I'm going to circle it because that's one of my answers. Now let's plug it back in here. So x equals 2 times negative 40/17 plus 7. That 2 is really a 2 over 1, so the 2 just goes to the top. Remember all of your skills that you've already got. Negative 80/17 plus 7. I hear you punching away in your calculators. If you put that in and then convert it back to a fraction as your final answer. Anyone else get 39/17 for x? Okay, so right here, we've got 39/17 for our x, and we got for our z, we have negative 40/17. Plug those back in to one of the equations that's up here. Now, obviously, we're not going to plug it into the bottom equation because the bottom equation only has x and z's. We're going to plug it into the top one or the middle one. So, which one do you want to use? Top one? Okay. So plug it into the top. 2 times 39/17 minus the y plus my negative 40/17 gets us to 4. 78/17 minus y minus 40/17 equals 4. Hopefully you're punching away. I'm going to move the y to the other side and move the 4 over here. So 78 minus 40, I have common denominator there, gets me to a 38/17 minus 4 gets me to my y. Do we have an answer? Anyone? Okay. Take it back up to your ordered triple, put it in for your y, negative 30/17. Use that convert to a fraction versus rounding your decimals. Your fractions are exact. Your decimals will be approximations. So respect that exactness, okay? Questions that you're having. Now, let's say that this bottom equation would not have been minus that y. I could have used the top 2 and gotten rid of a variable, used the bottom 2, got rid of the same variable, and then done a similar process, okay? So you might have a situation like that in your book. Do y'all have calculators handy so you're ready for some matrices stuff? How much matrices stuff did you guys do last year? Do you remember any? So like you added and subtracted them together. Did you guys talk about inverse matrices and any of that type of stuff, or did they keep it really basic? It's not like you, okay. All right. So my notes go a little bit more extensive than Mr. Flatham's with the matrices to just help you see. You're going to get to something at the end and go, oh, this is really nice. Okay. And then we're going to show you how to use your calculator as well. Okay, to help you get where you need to go. Now, things that we're talking about as we look at things is we still have our system of equations. Okay, and I would not use a matrix if it was just 2. But when we get to 3 variables and 3 equations, or 4 variables and 4 equations, and you're trying to solve things, matrices help simplify things tremendously as we go through. It'd be kind of the difference in long division versus synthetic division. If you think about how much you would prefer to synthetic divide than long divide, that's kind of comparable here. Okay, so as we talk about things in the way that there's description, your rows are denoted by the letter I. It's not a square root of -1 here. It's just saying that we're talking about if it's, we're talking about an element, and we'll get there. Your column is denoted by your J. So we can talk about an element in our matrix, and it's going to tell you it's A sub ij, and that ij, your subscripts, are just telling you the location that's there. So maybe I have something that says A13. That's telling you go to the first row, the third column, and tell me what the coefficient is there. I go to the first row, the third column, and my coefficient is a positive 3. That's what it's referring to. So it's purely descriptive. It's like you're the first student that walks in the room. You're the second student that walks into the room. What row, what column are we in? So if I have something like A sub 32, what element is in the third row and the second column? I go to the third row, the second column, and we're getting to that positive 4. Are you kind of with me at how it's just being described to you? Okay, so that will help you as you're reading and decoding things. Don't make those subscripts any harder than that needs to be. It's purely a name. It's giving you a description, a location of an element that's in your matrix. Now, your coefficient matrix, what it does is it takes our equation, it just takes the part that has the variables and the coefficients, and it just writes all the numbers together. So instead of writing, we just talk about our coefficients, instead of using x's and everything else, coefficient of here, I'm just going to write 1 and a negative 2 and a positive 3. In the second row, I have a coefficient of 2, positive 1. So I'm going to have to write the positive that's there. We'll just put 1 in its place. And then negative 4. And then negative 3, 4, and negative 1. That way, that's what's considered your coefficient matrix. It just takes all your coefficients and it puts it into a matrix together. Your augmented matrix allows your equations, what does it equal? It also brings in your constants. Okay, so what your augmented matrix is going to look like is the left side is your coefficient matrix, 1, negative 2, positive 3. And where your equal sign is, you put a dotted vertical line in that spot. So you're saying on the other side, the constant is 4. And then I've got 2 and 1 and negative 4 and 3 and negative 3 and 4 and negative 1 and negative 2. So that's getting you some lingo for if you're reading through some things in this particular section and you're talking about matrices, what they're talking about when they talk about coefficient matrix, your augmented matrix. Okay. Using these, what we're looking to do if we're talking about row echelon form, okay, in row echelon form, your main diagonal is all ones, positive ones. So I look at this main diagonal, and my goal for row echelon form is to get all of those to be ones. The second thing with row echelon form is we want the numbers below the diagonal to be zeros. So all of these numbers here we would want to be zeros. So a finalized row echelon form might look like that would be an example of a row echelon form. You've taken your variables out. You've created a main diagonal of ones. The numbers below that main diagonal are zeros. Okay. The benefit to this is now you can kind of put your variables back in. That third column represents z. This right here is saying, hey, z equals 6. 1z equals 6. So that's the point of our 1's. Now, this one right here would say 1y plus 2z equals 5. So if I know what z is, I would plug the 6 in. So I would get 12. Y plus 12 gets us to 5. So we get that y is negative 7. This top equation, I would have 1x plus 3y plus 6z equals 9. And since now I started with what z was and I have what y is, I can plug things back in. Now I randomly picked numbers here, so I'm not sure this is going to work out. If we plug things back in here, I would get 1x plus 3 times negative 7 plus 6 times 6 gets us to 9. Negative 21 plus 36 is 15 minus 15. Do we get x is negative 6? That's not too shabby of an example, I suppose. And our ordered triple for a random problem using row echelon form we could solve by back substitution. Kristen.
So first one, the example, like
Right here?
no
Okay, going back above.
with if the two the blue circle 2, -3 and 4, if that was zeros, would that still work? Because with that negative.
Well, then you would just divide both sides by that negative and you'd be okay. But our goal is to get that's there. Now, there's another thing that's called reduced row echelon form, RREF, we could call it. And what the reduced one even does is then it gets zeros up above. So you look at your diagonal and all you have is x equals, y equals, z equals, and you're done. Does that kind of make sense? Okay. It just depends on how comfortable you get with your matrices. Justin? I plugged in my z. Right, so z down here, this told me that z was 6. So now I go back and I substitute. I work up my rows then. So my z was 6. Now I'm going to plug the 6 in for my z here. And that's where that came from. Get my y and go up to the top equation and plug things back in. Okay. Some people really like it. Others prefer to still do use your top 2 equations and get rid of one. Use your bottom 2 equations, get rid of one, solve that, plug things back in. It's whatever's comfortable for you. Okay. So the next question is, how do we go from the one up above here that doesn't have a main diagonal of 1s? How do we create those 1s and how do we create those zeros? Okay. So in your book on page 675, of course, there's theorems. There's always theorems. Those are the rules. So as you're looking through and looking at what they are, this, I copied it right out, changed the fonts, changed the colors so that you have different ideas for what to do, okay? So if we are given a system of linear equations, we've written the augmented matrix, okay? It talks about things being equivalent. How do we not change the system, what we make things equivalent as we go through? These are kind of your guidelines. You can interchange 2 rows. So like if I don't like where row 1 is and where row 2 is, I could put row 2 on top of row 1 and just move things around. So as I'm looking at things, if I go back and I'm looking at something here, and like let's say row 1 was down in row 2 and that the first number was a 1, I would just interchange the rows so that my top number, my lead coefficient was a 1 to start with. That's all that one's saying to do. Okay. The second one says a row is multiplied or divided by a non-zero constant. I can multiply any row, just like I can multiply any equation by 2 or -3 or divide everything by 5 or 10, as long as you're doing things to the whole row. Okay. The starred one is one that you're going to be using a lot to create things. That's our most utilized one that we have. You multiply one row by something and you add it to another row to get rid of things. Okay, it's just like elimination. It's just that we don't have the variables that are there. We're not constantly rewriting x's and y's and z's. We're just manipulating the numbers. Is any of this familiar to you? Okay, so someone says a little bit and a lot of head shakes saying, nope, never seen this. Okay. All right. So this would be something to make sure maybe you highlight, you refer back to so that you've got it. The noting on page 675 is there as well, giving you helpful hints as to what can you legally do. Okay. So this one says solve using a matrix. So as we go through our example, your first step is to write it as that augmented matrix with just your coefficients on the left side and the constants on the right side of that dotted line. So I'm going to start, I've got 1, -2, 3, and 4. 2, +1, -4, and 3. -3, 4, -1, -2. And I'm going to make sure I write my 2's so they don't look like z's. I don't know, I'm on a kick, I suppose. Okay. Once again, our row echelon form will allow us to get to what z is, plug that in to find y, plug both of those in to find x using back substitution. Okay. We want our main diagonal to be all 1s. So we're in really good situation. This lead coefficient that's right here is a 1. That row is never going to change. Okay, so as I go through and I keep rewriting my matrix over and over and changing things to 1s and 0s, okay, that top line is going to stay the same. Now, you want to work down and then over and then down and then over. Yes? This one here? This bottom one? You want them to be positive at the end. Okay, and so if this lead one here was a negative, I would just divide this whole row by negative and just change all the signs, and I'm done. I've made that one positive, and I'm good to go. Okay, so my first thing that I'm going to do here is I'm going to change, I want to get that to be a 0. Okay, and I'm going to use my top row, and I'm going to multiply my top row by something so that when I add those two rows together, that becomes a 0. If this value here was a -2, then I could add these together and I could get to 0. Does that make sense to you? Okay. So how this is going to work is I'm going to say I'm going to change it. I'm going to multiply row 1 by -2, and I'm going to add it to row 2. That's the step that I'm doing. Okay. I'm going to leave my top row alone. And then I'm going to do what this says all in my head and put the result in row 2. So -2 times 1 is -2 plus 2 is 0. -2 times -2 is 4. 4 plus 1 is 5. -2 times 3 is -6. -6 plus -4 is -10. -2 times 4 is -8. -8 plus 3 is -5. Are we okay so far? Ask your question. Okay, so I'm multiplying the top row by -2, and then I'm adding that to my row, my second row. So -2 times 1 is -2. -2 plus 2 is 0. Okay, we're very good at multiplying and adding, so that this is one of those that eliminates the step of saying, I'm going to multiply it by 2 and show that equation, and then I'm going to add them together and show that something eliminated. Basically, we just eliminated the x in the second row. Is what we did. Does that make sense? Okay, only we left all the variables out of things and kept things organized. Are we okay now? Okay. It seems way harder. It might be. Okay, might be. Now, we didn't change the bottom one at all. We had -3 and 4 and -1 and -2. We just changed that second row. Okay. So we talked about working down and over. So I got my 0 where I want it. I want this one right here. I'd like that one to be a 1. Okay, to create zeros, I'm going to add rows together. To get that to be a 1, can I just divide everything in that row by 5? Yeah, okay. So to create this, the next thing that I'm going to do there is I'm going to say, well, I'm going to take row 2, and I'm going to divide by 5. Everything else is going to stay the same. I'm not going to change anything else. 1, -2, 3. Okay. My second row becomes 0. I divide by 5. I get 1. -10 divided by 5. I get 2. -5 divided by 5. I get -1. Yes.
What if it was that clean cut, where it was a fraction?
You could, yep. To create your 1s, you're probably going to divide. Okay. Get your 0s in that row first. Your 1 is going to get there last. Because if I create the 1 first and I haven't done the 0, when I re-add those equations back together, that 1 could change. So that's why you work down and over to create this. Yes. Yes, thank you. -2. Okay. I didn't change anything in the third row yet. -3, 4, -1, -2. Okay. Now, we're good here. We have in our main diagonal, we've got our 1s, we've got our 0. The next thing for us to do is to change that one to a 0. Okay. So if I look at things, in order to get this one to be a 0, if I multiply the top row by 3, 3 times row 1 plus my row 3, that's going to create a 0 in that spot that I want it to be. My 0, 1, -2, -1 doesn't change. This one here, I'm going to do my 3 row 1 plus my row 3. So I go back, 3 times 1 is 3. 3 plus -1 is 0. Do the same thing to the top. 3 times -2 is -6. -6 plus 4 gets us to -2. 3 times 3 is 9. 9 plus -1 is 8. Finishing off the constants, 3 times 4 is 12. 12 plus -2 is 10. Okay. So we've got our 1s, we've got our 0s. We want this now to also be a 0. We're working over. We want that next one to be a 0. Okay. For this column to create zeros, we used row 1. To create a 0 here, I'm going to use row 2. Because row 2 has a 0 here and a 1 here. So now these I'm going to use to cancel out. My row 1 stays the same. My row 2 stays the same. And what we're going to do here is I'm going to multiply my row 2. I want this value. I want my 1 to, I want to get this 0, so multiply it by 2. 2 times row 2 and I'm going to add it to row 3. I'm going to eliminate the y in the third equation. So if I go through and I use my row 2, I'm multiplying using my row 2. I've got row 2 is 0 times 0, or 0 times 2 is 0 plus 0. I keep my 0. 1 times 2 is 2. 2 plus negative 2. I create my 0. 2 times negative 2 is negative 4. Negative 4 plus 8 is 4. 2 times negative 1 is negative 2. Negative 2 plus 10 is 8. Questions floating out there right now? Are we okay so far? Now, this last value we have, this is in our main diagonal. We want that to be a 1. This is where we're just going to divide by that value to create that 1. Everything else stays the same. 1, negative 2, 3, and my 4. 0, 1, negative 2, negative 1. 0, 0, 1. I divide by that 4. I get a 2 on the other side. Describing what we did, row 3, divide by 4. Your book might say that's row 3 times 1/4. It's the same thing. Scalar multiplication and division is the same thing. So it's a little bit of work because you haven't done it before probably. It's a way to organize things as you go through. This tells us now at the end that, hey, z equals 2. In my ordered pair, or my ordered triple, my z value is 2. And now you're going to back substitute. The second line tells us I have 1y minus 2z equals negative 1. Plugging my 2 in, I get y minus 2 times 2 equals negative 1. Y minus 4 is negative 1. So y is 3. Plugging both of those back into our top equation, x minus 2y plus 3z equals 4. Plugging things in their spots, x minus 2 times 3 plus 3 times our z value of 2 gets us to 4. And I have x minus 6 plus 6 gets us to 4. So we just get that x is 4. On pages 676 and 677, they give you some helpful hints in those boxes. There's a blue box and there's a pink or red box, depending on how you see that. Okay, and they give you some helpful hints as to how you can do your row echelon form, what's going to help you, ideas of where to start. Definitely something to read about as you're trying to practice with your matrix. Okay, and Randy, yeah, it does take time because you've never done it. But it's a great way to organize things if you were struggling on the solving the other way. And eventually, you're going to get really fast. If I go back a couple slides and I look at, go back to that one slide, and I look at where we started, I went step by step to show you what to do. If I were to do this on my own and solve this system, I would get a 0 here and a 0 where the negative 3 is in the same move. And I would write right next to it, I multiplied negative 2 row 1 plus row 2 to get a 0 here. And I multiplied 3 row 1 plus row 3 to get this one to be a 0. And I would do that at the same time instead of rewriting everything in all one fell swoop. I worked down, got my zeros. My next move then is to for sure make that one a 1. And then I have to make that one a 0, and I would probably do that at the same time. I would transition that, and I would write the next thing down, get that a 0, and then make that a 1 by division. So you can simplify it as you get better. If I would have done both of those things right away, what the heck would have happened, right? You're going, what am I doing? But you can, as you're getting efficient with things, you can do shortcuts and eliminate writing over and over and over, okay? But that slide that's here, it talks about make your upper left number a 1 first. If you can interchange your rows, do it. If one of yours starts with a lead coefficient for x is 1, move that row to the top. That part's done. Get a 0 in A21. Remember we talked about our row is our second row in our first column. Get a 1 in A22, or you could also get a 0 in 31. 0 in A31, okay? Would be something else to add there as well. And then work your way down from there, okay? If you want to go step by step, so you show every single thing, that's okay. If you can do 2 things at once, that's all right too. Okay. Okay. Your special situation sometimes that we notice that maybe there's not one answer. Maybe these planes don't ever intersect. Maybe we have 2 lines that don't intersect and there's no solution. Maybe we have the same line when we're trying to find things. Everything's in the same plane. What does that look like when you're dealing with a matrix? Okay. So here we go. We're going to solve this one by a matrix. We might run out of time. We'll pick up here tomorrow if we run out of time. Okay. Start with your augmented matrix. And as I'm writing this, if that top one didn't have a lead coefficient of 1, I would not have written it in that spot. I would have interchanged the rows right away to save me a spot as I'm going through, okay? So looking at it, I'm good here. I have a 1 in the top corner. That's exactly what I want it to be. I'm going to change this one to a 0. Now, can we try to do it efficiently at the same time and change the bottom one to a 0 at the same time? Do we want to try that, or you want me to go step by step? We can try it, okay? All right, so how this is going to look, I notice my top equation never changed. Once I get that 1 there, it never changes, okay? So to get a 0 in this spot right here, I need to just subtract them. I'm going to take row 1 and subtract row 2 to get that 0. So as I do it, I go 1 minus 1 is 0. 3 minus 1 is 2. 1 minus negative 1, be careful, that's a chop chop, gets me a 2. 0 minus 0 is 0. The third line, I'm going to create this one and get this one to be a 0. In a similar way, I'm going to use the top equation, row 1 minus row 3. So 1 minus 1 gets me a 0. 3 minus a negative 2 gets me a 5. 1 minus a negative 4 gets me a 5. 0 minus 0 is 0. I worked down. I have a 1, and then the 2 numbers below it are zeros. The next spot we want to go, we want to get this one right here to be a 1. What are we going to do? Divide by 2. Good. Okay. So my top row is going to stay the same. Okay. I'm not going to change my bottom row yet. That's going to stay the same. My second row is going to change. I'm dividing by 2. So row 2, divide by 2. 0, 1, 1, 0. I've gotten 1s, I've got my 0s, I need to work down and over again. I need this one to be a 0. We're in the second column here, so we're going to use that second row. What can I do to row 2 in order to get a 0 in row 3? What do I have to multiply it by so we can add them together? If this was a -5, that would be really good. So we'll multiply by -5. I keep my 1, my 3, my 1, and my top stays the same. My green equation is going to stay the same. We're looking to change the bottom equation. I want this to be a 0, so I'm going to multiply -5 times row 2 and add row 3. -5 times 0 plus 0 gets me 0. -5 times 1 plus 5 gets me 0. -5 times 1 is -5 plus 5 gets me 0. -5 times 0 plus 0 also gets me 0. Everything disappeared. That third equation, there's no way for me to get that to be a 1. So what is this telling us? Z is not 0 because I don't have a 1 there. I have no x, I have no y. This is saying that 0 equals 0. Is that a true statement? Does 0 equal 0? Yeah. So this is a situation, okay? And we'll talk about it tomorrow, that this is your infinitely many solutions. But where do we go from here? How do we get our answers when it's an arbitrary answer? And we'll pick up here and we'll finish tomorrow, okay?